on to question number 7. Alright, so question number 7 reads, what is the quotient of x cubed plus x squared minus x minus 1 divided by x minus 1? Okay, so we're going to be using 2 different methods. So the junior tutor uses synthetic division to find the answer, and I'm going to use long division to find the answer. I'm going to go through both with you guys today. Okay, so long division and synthetic division both try to do the same thing. It essentially tries to figure out whether or not a possible factor of a polynomial is actually a factor. So when we look at this quotient x cubed plus x squared minus x minus 1 divided by x minus 1, this question is basically reading, is x minus 1, so another way to write this is x minus 1 a factor of x cubed plus x squared minus x minus 1. So that's another way to read this question. Okay, so how do we know if x minus 1 is a factor of our polynomial here? Well, as with regular numbers, if a divisor is a factor of the dividend, the quotient will not have a remainder, right? So for example, if we were to divide 63 by 7, we know that 7 is a factor because there is no remainder, right? There's no fraction involved. In the same way, we can do long division or synthetic division and determine whether a factor is actually, this possible factor is a factor by seeing that there is no remainder. If there is a remainder, then we have to go back to the books and try to find another factor. Okay, so I'm going to go through long division first, and I'll go through synthetic division. I'll go through how to do each of those, and then you guys can choose which method you find to be more intuitive for you guys. Okay. All right, so let's do long division first. All right, so long division, we're going to write out this huge division bracket here. We're going to put our polynomial in here. Okay, x cubed plus x squared minus x minus 1. Okay, and we're going to write our possible factor, which is x minus 1 here. So we're going to try to reduce our number by multiplying our dividend, or divisor, by a certain factor. Okay, so we want to get rid of x cubed plus x squared, right? We don't want that in our actual quotient, right? So what can we do to our divisor to try to get rid of that? We can multiply this by x, okay, or x squared. So I'm going to write x squared here. So x squared times x minus 1, if we expand, we're going to get x cubed minus x squared. Okay, we're going to subtract like in regular division, and we're going to get 2x squared. Okay. So you kind of see how there's a semblance of division here, right? We multiplied our divisor by a factor, and we're trying to reduce our dividend. Okay? So we're going to move our next term down here. So minus x. So what factor here can we multiply to get rid of this number here, or this factor? So we're going to say x, right? So let's do plus 2x. Alright, so if we do plus 2x, we get 2x squared, right, if we expand here, times negative 1, so it's minus 2x. And if we subtract, we get x minus 1, or just x, sorry. Getting ahead of myself. And let's carry down our last term here, which is minus 1. Alright, so how do we get rid of this x minus 1? We're just going to multiply our factor, our divisor, by 1. And this is what we get, x minus 1. And if we subtract, lo and behold, we get a remainder of 0. So now we know the quotient is going to be x squared plus 2x plus 1. Alright, so let's do synthetic division, or what the junior tutor did, okay? So synthetic division. So instead of writing our polynomial, we're going to write upside down. Sorry, let me write down a bigger bracket here. An upside down bracket, division bracket, and we're going to write the coefficients of our divisor, or our dividend. Okay, so our coefficients are 1, right? So the coefficient x cubed is 1. Coefficient of x squared is 1. The coefficient of x, or negative x, is negative 1. And the coefficient of negative 1 is negative 1. Okay? And now we're going to think about the solution or the zero. Okay, so instead of thinking about the factor, we are going to think about its zero, right? So if x minus 1 is a factor of this, then the zero or the solution to this polynomial is going to be 1, right? Because that's what makes this to be equal to 0, right? So how synthetic division works is we're going to carry down our first term. So we're going to carry it down here. All right, sorry, give me a sec. We're going to carry it down here. And we're going to multiply our factor to this carry down and subtract it to this factor, or add it to this factor, okay? So if we do that, so 1 times 1, so I'm going to do the arrow here just to show you guys. 1 times 1 is equal to 1, and we add that, plus 1, right? So this is going to be 2. So now we're going to carry this down, so 1 times 2. So let's do another, I would draw another arrow. It might get a little bit messy here. So 1 times 2, we're going to carry it over to our next one, plus 2. So that's going to be 1. And finally, we're going to carry down our last one. So 1 times 1. Sorry, let me just carry it over here. Oh my gosh, this is kind of messy. So 1 times 1, so plus 1 minus 1 equals 0. Okay, so what does this mean, right? So if you have a 0 at the end of your synthetic division, that means that you have no remainder, right? And if you have no remainder, then you know that x minus 1 is a factor of x cubed plus x squared minus x minus 1, or the quotient is going to be, so if this is the x cubed position, and this is the x squared, and this is the x, and this is just the constant, then this is going to be, since you're dividing it by a factor, this is going to be x squared, x, c, and this is going to be your remainder, right? So our remainder is 0. So whenever you're thinking about synthetic division, your quotient at the end is going to be 1 degree of power lower. So if this is x to the power 4, this is going to be x to the power 3. So if we're going to apply these coefficients now, it's going to be x squared plus 2x plus 1. No remainder. So these are the quotients of this division. And I've shown you guys 2 different examples of long division and synthetic division, okay? And we got the right answer. So this solution is correct. Good work. All right, let's move on to question